So just a disclaimer, I am not going to go deeply in depth into the work that I did just because of time purposes, but I am going to explain the overall purpose of it. So I'm doing the migration of turtles. So my dominant alleles will be the pink turtles, my heterozygotes will be blue, and my recessive will be green. So 150 turtles are looking to come over from the mainland to join the 700 turtles that are on the island, just because obviously there's less population on the island, so more vegetation to eat. So here are my genotypic numbers for the individuals. So M is the proportion of migrants after immigration occurred. So we're looking for after it occurred. So we're taking the total number of the island and then adding the number that are coming over, giving us 850. So we're taking the people who are coming over, dividing it by the total population, and I get this percentage, which, so in this case, the island gets immigrants from the mainland at a rate equal to 17.65% of the total island population per generation. So here, we're just looking at the genotypic arrays. So as you can see on the mainland, overall there are 53% are pink, 33% are blue, 13% are green, and then on the island initially there are 4% pink, 31% blue, and 64% are green. But P is the frequency of the big A allele on the mainland, and then little p is the frequency on the big A allele on the island initially. So this is what happened when migration occurred. You can obviously see that there are more pink turtles now on the island. So this all happens after migration occurs. So we're trying to find the allele frequency of the genetic array on the island after migration. So at the top I put the proportions that we found beforehand for the frequencies. So P prime is the frequency after migration. So we've in this equation, plugged in all the numbers that we got before, and I got this, Q prime, 1 minus P prime, and then after migration I got this allele frequency, and this does not allow you to get the genotypic frequencies since the genotypic frequencies will not be in equilibrium. Here we're trying to find the genotypic frequency, so once again, I put the previous information at the top, but basically you're just doing P prime all over again for each genotypic frequencies, and I got this for the genotypic array. And once again, the population isn't in Harvey-Weinberg equilibrium, so how can we get it there? Randomly mate one generation without allowing any violations for assumption is one way.